This is a problem worked through for lesson 2.6, Gravitational Acceleration and Free Fall. This is problem 59 from the workbook. Now, a stone is dropped from a bridge and it strikes the water 2.5 seconds later. What we are told in this problem is two important pieces of information. The stone is dropped from the bridge and the 2.5 seconds. What this tells us is that we are dealing with a gravitational free fall problem. So the stone dropped from the bridge, our initial velocity is 0 meters per second. It also tells us that our time for this drop is going to be 2.5 seconds. Now, in the problem, part A, it also says that our unknown, our ask, is going to be the final velocity. So what is the final velocity? VF is our question mark. Since this is a gravitational freefall problem, we know that g, the force of acceleration due to gravity, is 10 meters per second squared. Now the formula from acceleration that will relate initial final velocity, time, and acceleration due to gravity is the formula VF equals VI plus AT. In this case, we'll do GT. Now we've already solved the formula for our unknown, so we don't need to manipulate it at all. All we need to do now is just plug in our values. VI is 0 meters per second. The force of gravity, the acceleration due to gravity, is 10 meters per second squared. And then time is 2.5 seconds. Now this is a 0. We really can ignore it, but we do need to make sure that the units match up. Now meters per second squared multiplied by seconds, this second will cancel with one of the two here. So we get 0 meters per second plus 10 times 2.5, which is 25 meters per second. That gives us a final velocity of 25 meters per second for the stone that is dropped from the bridge. Now, part B asks how high is the bridge? That means that x, displacement, is our unknown, and we can actually choose any of the three remaining formulas for acceleration to solve this. Realistically, though, the simplest formula will be x equals VF plus VI over 2 multiplied by t. Now, if I scoot this up a little bit so we have room to work this problem, let's see. This way we can still see all the values from the first part. So all of these values will be used for this formula. Initial velocity, time, and we did solve for the final velocity here. So when we substitute our values in, final velocity is 25 meters per second. Initial velocity is 0 meters per second. This is divided by 2, and we multiply by time, which is 2.5 seconds. So multiplying through, this term, the v sub I at 0, disappears. So 25 divided by 2 is 12.5 meters per second, multiplied by 2.5 seconds. If we bring through our calculator, we can see that 12.5 times 2.5 is 31.25. So 31.25 meters, because seconds cancels with seconds and we're left with meters alone. 31.25 meters equals our displacement.
And I'm Tiffany Miller.